Hello, my name is Alberto Pascal, and today I will be showing you my approach on the Minesweeper problem for the CS50 AI Python course. I will be covering a small explanation on the known mines, known safes, mark mine, and mark safe function from the sentence class, and add knowledge, make safe move, and make random move from the Minesweeper AI class. First of all, the known mines. This method should tell me whether a mine is certain or not, and to do this, we can take, for example, a set of cells A, B, and C and a count of 3. This should return all of these 3 cells as mines because the length of the list is the same as the count. However, having the set A, B, and C and a count of 2 should return nothing because we cannot be sure which of them are mines. Similarly, our known-safes function will do exactly the same, except we will return the list of cells only if the count is 0, because this means that all of the cells are safe. Otherwise, we have uncertainties and we cannot return anything. When marking a mine, we have to remove the cell as part of our sentence and decrease the count of mines. So for example, we had the set of cells A, B, and C, and our count was 2. Removing the cell C, which is a confirmed mine, would result us in updating our sentence to be A and B with a count of 1. Similarly, our marked safe function will also remove the cell from the sentence, but will not update our count of mines. So for example, our set A, B, and C with a count of 2, when removing the cell C that happened to be a safe, results in the sentence A and B with a count of 2, which itself is also giving us more information, but we will be looking at this further on. Now, the add knowledge function is probably the most important function from the Minesweeper AI class, and in this function we should mark the cell as played move, mark the cell as a safe, add a new sentence to our knowledge with this cell's neighbors, mark any additional safes or mines, depending on how we update our knowledge, and determine if there are any new rules that can be inferred. And how are we going to achieve this? Well, the marking cell and marking safe is pretty simple because to mark the cell as a plate, we just add it to the moves made list. And to mark the cell as a safe, we can just use the mark safe function, and this would update our sentence and remove that cell from all of our sentences. Now, adding a new sentence to our knowledge with the cell's neighbors just requires us to iterate through each of the cell's neighbors, so through each of the boundary cells, and add it if it is not already a confirmed safe. Now, when updating our knowledge, we need to take into account that when we marked the cell as safe, we removed this cell from their sentences. So it might result in us having something like the set of cells A, B, and C and the count of 2 before, but when playing C, we kept the sentence A and B with a count of 2, from which we can interpret that A and B are confirmed mines. So the objective of this part of the function is to iterate through every existing sentence and reevaluate its meaning. And finally, the adding new rules that can be inferred is just to iterate through every sentence again and try to apply the following formula, which is set 2 minus set 1 equals the count 2 minus count 1. And these will allow us to create new rules that might not be in our knowledge base. If we happen to come across one of those, we add it to our knowledge base. And the make random move function will create a random cell and check if that cell has already been moved or a confirmed mine. If it is not, I return this move. The possible outcomes of this is that I have my AI win the game and mark all of the mines, or my AI run out of safe moves and lose the game. So let's take a quick look at the game. Here I have my game. I'll run Minesweeper, play the game, and I'll start playing with my AI. So as you can see there, those were random moves and I immediately lost. But when finding a 0, my AI will detect the safe moves and move practically all of the cells around zeros first. Fast forwarding on this. Here, for example, I have a confirmed mine. I'm not playing these, neither here, neither here, neither here. So the AI got pretty close to finishing, but I ran out of safe moves, which resulted in a loss. Now this time, I'll be showing you how the AI can win the game. So fast forwarding another test scenario. Here we see the AI getting pretty close and finally marking all of the mines. So that would be it. Thank you for watching and see you all in my next video.